Thanks, Jeff, for the intro. My name is Nate Bergen, and my job here is to introduce Ralph Austin to you in so many words. I joined. Sorry, this one. Page down. Okay. I joined Seagate Structures about 4 years ago now. Ralph's team, and Ralph he's been a carpenter for his whole life, and had a inspirational moment years ago, and decided to move into sawmass timber as the way of the future. And I've joined his team and am helping him to get to where we want to go. So who we are builders. We're carpenters by trade, and we understand you call them intricacies, but we understand how the right way to build things. We've seen a lot of the wrong way to build things, and sorry. When we start moving into things like mass timber and see simplistic structures and see how much better things can be, that excites us. Here we go. So what we do at Seagate is we offer design assist services. We like to get in to the discussions early with developers, architects, and engineers. We find that if we can offer input on buildability early, we can influence how a building goes, either for the good or for not. So when we come in late to the discussion, we end up getting handed something that we end up having to build, and we fight through different issues that could have been resolved earlier. Okay, so we offer design assist, as I mentioned. Procurement, we're very familiar with lightwood frame construction and mass timber. And as Jeff said, our most notable project to date is the Brock Commons project. We endorse prefabrication. We have a facility in Chilliwack, Lower Mainland in BC, where we prefabricate walls and glue-lam and CLT as well. Installation-wise, that's really our forte. We excel at putting things together on site, take it from our prefab shop, and make it happen on site. Just a few of the projects that are most notable. Ralph's first project, this is before I started with him, Mountain Equipment Co-op, 100,000 square feet of NLT on post and beam. Grandview Aquatics Center, which won, I think, the International Structural Award, was it last year? For engineering. UBC Baseball. That's an interesting project. It turned into what was our first wood tilt-up construction. Brock Commons, I think almost everybody knows that one. 5-story post and beam at Kwantlen Polytechnic, and Virtuoso, also a UBC project. And that seems to be the model that a lot of people are drawn to, CLT floor system on lightwood frame walls. And then we look forward to this year. Our big project is MEC flagship store in Vancouver, which is also post and beam CLT floor structure. And I'll let Ralph take it from there, and he'll tell you how we make the magic happen.
Yeah, when Jeff first asked me to come and talk to this panel, to be part of this panel, to talk about how mass timber could solve affordability crisis, I thought, well, that's not going to work, because you know what? We're suggesting to put a product in a building that's more expensive per square foot than most others, even concrete. So I thought, well, that's not really going to be a solution. But then I thought, well, maybe if it's a supply and demand solution, then maybe we can help, because I know for sure the use of mass timber encourages more off-site prefabrication. It encourages more pre-planning and more trade coordination and faster and just-in-time deliveries and faster and smoother installations. So maybe we can increase the supply. The prices will go down, So that's my thesis of the topic today. So in that regard, I think, like, I'd love to be able to talk to you today about some of these big, tall, sexy projects that we've done, Broad Commons and Terrace House and different things that are above, like, mid-rise buildings. But to be honest, we're not quite there yet. The code isn't in place. There are hassles with getting the permit in the first place and getting code approvals and fire approvals for anything over, what's currently under code. So let's leave that for another day and let's concentrate today on what we can do. And I know the best model today for what we can do is the low-rise wood frame, a model up to 6 stories in our jurisdiction, maybe 5 in yours. And I think that's where CLT can come in and play a role to improve our lives and improve the affordability issues that we face. So light wood framing, like, I've been involved in framing apartments for longer than I can remember. In fact, my first cell phone was the size of my work boot, basically, and I can remember it falling down a building 4 stories tall, and it survived just fine. But over those, whatever it is, 25 or 30 years, it's kind of embarrassing to see the modest improvements we made in construction, if any, in the time that my cell phone is now the size of that and can, connect to the internet. And we're still basically building the same way we did when I started in 1990. So for sure we got to make improvements. So, and when I say improvements, I don't know if you go to this guy. Like, anybody that knows me is going to kind of be like, enough with the 4 things, Ralph. I know I say this to everybody I've met for the last couple of years. There's a way to make improvements. And this guy here, they're his words, Oscar, if you're in the audience, and not mine, Shigeo Shingo. He said, if you want to make improvements, you start by making it easier, better, faster, and cheaper. But most importantly, you do it in that order. And I don't know how many times I've gone to an owner or an architect and we talk about what CLTs and get up through all that stuff, right? And then they talk about the cost. Is how much? How much per square foot? Okay, yeah, we'll get back to you. Yeah, and then that's pretty much the end of it, right? But and that's been, I guess, 3 years I've been talking like this. But over the last year, even after the last, 8 months, because labor, the shortages are like dire in most of the urban centers now. And owners are realizing that if they go through these 3 steps, make it easier, make it better, make it faster, the cheaper will follow. It's just they're actually happening. Virtuoso was our first about this time last year, and now we've got 4 more, including another one here coming up in Seattle for our friends at Katara. So it's actually moving in the right direction, which is very encouraging. Okay, so I'm going to talk to you today about putting CLT into wood frame structures. And when I say putting it in, I just mean just in a horizontal application, just replacing the 2x10 or the TJI floor with CLT panels, 3 or 5 ply mostly, right? I know at some point we're going to get to the point where we can put CLT into these buildings in vertical applications too, to use them as load-bearing walls and shear walls. But the engineering community hasn't figured out, at least in a seismic zone, how all that works. They're too rigid or something in the seismic doesn't work. So that'll be a year or 2 or maybe more away. But for now, we're just straight up switching out the floor panels for CLT. Okay, so I was going to say, okay, how are we going to prove that this is easy? So this plan here is a building we're doing right now in Vancouver. It's 4 stories over 2. That plate there is 18,000 square feet, and that image there is level 6 floor over level 5 walls. And it's commonly known, if you can see it, you probably can't see the details, but it's basically a dog's breakfast, is what we call that. Yeah, it's just, because what they do in Vancouver, they go typical, 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 and then the 6th floor, they like, okay, let's pull in the front, pull in the back, pull in the sides, make the units wider. And it's like, that's what you got to do structurally. Right, so so what it is like, and then I thought, well, how can I demonstrate that graphically, right? And so I've often said when we do these mass timber jobs, like the one Nate mentioned, Grandview Heights Aquatic Center, it had 116 paired beams. I mean, we install that in like a finite number of days, right? We could calculate that. Broad Commons, Brent, was 78 columns and 29 panels. Like, you can count times 16 floors. So you can count the pieces. Good luck trying to count the pieces in a light wood frame building that's 4 or 6 stories tall. Well, I did. Yeah, so what we got here, because we prefab all of our walls, we got 600 panels to make up that floor I just showed you, right? And I'm not mentioning it now, but of those 600 panels, they're all about 12 feet long average. There's about 20 pieces in that. So there's another 12,000 pieces that have already been put into this project before it gets delivered to the site. But that's in our plant, and that's kind of controllable, and that's cool. Right? But now we got to stick frame the floor, right? We got 6,700 joists and beams and pieces of plywood to put into the floor, lots of blocking, a million blocks, a million flush beams to pick up those point loads I told you about. Joist hangers, seismic anchors, 835s, LPT4s, like a million pieces to put in, right? So there's the ratio. 13,000 pieces to do 18,000 square feet. So 700, pieces basically per 1,000 square foot. And the thing about that is, okay, well, that's cool, but the problem is, I don't know if you go back to that diagram, but like you're foreman, you have to have good guys to know where to put all those pieces. Right? You have to have a good crew and a good foreman who has to know the details like the back of his hand. And speaking of details, that job there has, I think, 7 or 8 pages of like wood frame details. 84 the typical details the guy has to watch for. The guy has to be good and have the eyes in the back of his head, right? So it's a tough thing to do, right? And we tried to prefab these things at one point. We did one job. Well, let's just make cassettes and we'll do them on our shop, right? But then it costs almost the same to build in the shop as it does in the field. Then you got to store it, then you got to truck it, then you got to put it up, and you're basically shipping air. So the economics don't work, so we gave up. So now we're stick framing just like this. Okay, so let's compare this to a Broad Commons project. Brent, who's here, can chime in on this. But we had a typical floor that was 8,600 square feet. We had 78 columns and 29 panels, and 100 drag straps and spines and different things. So 200 pieces to do 8,600 square feet. So 24 pieces per 1,000. So it's like not even close. I know it's not fair because we didn't build the walls. I think there's 24 perimeter panels that made up the exterior wall, and then they had to stick frame all the interior partitions and all that stuff. So it's not really a fair comparison. So let's go to a hybrid project like the one we did for Virtuoso last year. Well, this is actually the one for Katera coming up in Shoreline in the summer. And that typical plate is showing Building A, which is 21,500 square feet. And we've got about 800 panels to make up the walls and about 120 floor panels. Yeah, so here we go. We got, and obviously the seismic hardware and all that stuff. So we got about 900 pieces to do 21,000 square feet. So now we're at 90, pieces per square. And now we can talk. Now we can make some progress, right? We don't have to have the skilled crew. You don't have to have a foreman with eyes in the back of his head. So there really is no comparison. As far as easy, I think we can all agree that going with the CLT floor is going to be easier than going with a stick frame floor. So let's check that off. Okay, so now the next step is to make it better. Okay, so how do we qualify making it better? And there's a number of ways, but I think, the best one, and the one I like the best, is when I referred to the lack of advancement in industry over the last 20 or 30 years. Well, for once in our life, we're doing a job that actually encourages collaboration and comprehensive planning and pre-planning and off-site prefabrication, digital prefabrication. This photo here on the left is a guy that basically built Broad Commons in 3D before we built it, right? Right to the minutest of details, right? So the building was already built. When we started, it was go time. There was no stopping. We knew there was no site change orders, no site instructions, no what do we do here? It was go time, right? And that picture on the right, it shows me in the middle. There's the project manager and the architect and the owner. This is the one that day the last panel went up, right? Well, on a normal project, I've already hated the engineer for months. The project manager, I'm sick and tired of him phoning me, asking me to put more guys, you're going too slow, right? And I don't even want to make eye contact with the owner. But you know what? But this project, look at that. That's the way construction can be, with a little bit of planning, right? It's not really rocket science, right? And then, well, a lot of planning, true enough. But anyway, the other benefits are, like a CLT floor, it doesn't squeak, it doesn't bounce, it feels like concrete. It's got better fire characteristics, for sure, and better sound characteristics. It's more precise. And during construction, I don't know if we have a photo of Virtuoso there. During construction, I don't know if the owners are here, and they might not be saying this. We actually had somebody try to burn down Virtuoso during construction. They set a fire in the stairwell, right? And it was, I don't know, luckily it was at 5 o'clock in the afternoon, and somebody noticed and called the fire department. But 20 minutes, it had climbed up the studs, and it hit that second floor CLT and scorched along there a little bit. It's creeped a little bit up onto the second floor, but the fire department came, put it out, it was all good, right? Well, if that was a light wood frame job and it had 20 minutes to get going, it would have been gone. It's totally gone. So I think it's a safer way to build as well as being a better way to build. Okay, step 3 is make it fascia, and this is where we shine. This is, it's just amazing the productivity you can see. And I want to comment, like, that's not my photo. I didn't do that graphic. I mean, obviously the guy's on his break. Give him, he doesn't have a rest, right? So anyway. Although I did have one guy on a job about, I don't know, 8 years ago or whatever. I was looking for the glue gun, and I went to look for it, and there's one unit, I knew I saw it last, and I looked behind a piece of plywood, and there was Phil having a nap behind the piece of plywood. Right? So it can happen. I can't say it doesn't, but I don't think that's the case there. But yeah, again, productivity has been in steep decline since I started here. And I think that's more to do with the complexity than anything else. It's not necessarily that the workers are less skilled, maybe a little bit, but it's mostly that the jobs are getting beyond their capabilities, right? And for sure, there's not as much incentive to go into the construction industry because, you know, it's not as cool and as sexy as some other endeavors that a young guy might enjoy. But for sure, I mean, we're facing productivity losses all the time. So this project here was one we did at UBC, and it says the good old days, but it was only in 2011, I think. Yeah, so we did this project. It was 100,000 square feet, and we did it in 12 weeks. It was like 4/2. It was modestly engineered for seismic. It didn't have, I think it had 120, hold down runs. Now that job would have double that, 240 probably, so it went pretty fast. It was a nice, easy job, went pretty fast, and our productivity rate, including this on-site prefab, was 115 hours per thousand. That's how we measure our productivity, right, in our framing company. This one here, we just recently finished, right? It was prefab walls and stick frame floors, and we were averaging about 5,000 square feet per week with 18 workers, and our productivity rate dropped to 200 hours per thousand, and that's with the walls already coming to us prefab. That took probably another 40 hours per thousand in our shop to build the wall panels, right? Okay, well, here's our gold standard, of course. We'll go back to Broad Commons. Yeah, we did 2 of these 8,600 square foot floors in 1 week with a crew of 10. Our productivity was 43 hours per thousand. It was just off the charts. It was just crazy to believe, right? Okay, so again, we left that job without having any partitions, and so it's not really a fair comparison. That's cool. Yeah, but we did Virtuoso, like just last year, and it was 115,000 square feet, typical 6-story apartment, right? Just the likes the ones you see on the side of the freeway when you're going down I-5. Yeah, and it was pretty complex, like wasn't the perfect example for a perfect one to start for a CLT job. The panels were small, a bit chopped up, there were steps and all that stuff. But we did it in the dead of winter in 14 weeks with a crew of like 18 guys. So our productivity was 8,200 square feet per week and 150 hours per thousand. So that's going in the right direction, right? This next one we're doing is for Boza on Low Heat Heights, and that we expect to do a floor a week. So again, our productivity is a lot simpler. Our productivity will be a little bit better, right? So in comparison, if we go down to the olden days, and the olden days, like, I mean, that really was only 2011. So in the old days, we used to do 80 hours per thousand, but those days are long gone. Yeah, but just looking at this chart, and I don't have it here, but like say we did, now we can do like a conventional frame job. We do 5,000 square feet per week. If we introduce a hybrid into that, and we can do like say 9,000 square feet per week, that delta is 4,000 square feet per week. We do that for 50 weeks out of the year. That's 200,000 square feet. One crew can do more per year. That's 2 Virtuoso-style buildings on the market every year. That's one crew. If we do that with 10 crews like us, then there's like 20 buildings like that. So housing for 2,000 more people. So I think it's fair to say that CLT projects can make faster, reduced crew sizes, improve productivity, and faster build times. So making it cheaper is our challenge. So, and this is ones that we always fight with. We always have a debate with the architect and the owner early on about the additional cost, right? And rightly so, it's their money and it's valuable to them, right? So just to put it in perspective, the labor cost now for like standard wood frame projects, the one we did in Vancouver was $21 per square foot. That was about 2016, 2 years ago. A recent one in Burnaby was $25 per square foot. And this one we're doing right now, the first example I showed you on the board, that's around $27 per square foot partly because of that dog's breakfast I showed you, right? And again, Brent, folks, don't throw your shoe at me if I'm wrong, but I think my best guess, because we didn't do the supply and install on this project, we just did the install only, so I don't know the numbers for sure. Brent here does, but he's not sharing. Yeah, but my best guess is $42 per square foot if we just count the glue lam and the CLT, our install time, and the cost of the concrete formwork rebar for 16 floors. We did 16 floors, right? So $42 per square foot. So I don't know. Yeah, again, it's not really a fair comparison because it's a little apples and oranges. So, but this Virtuoso one, our labor was $10 per square foot. The CLT cost 12. The walls and all the hardware cost 10. So it was our $32 per square foot to do this hybrid type of building versus the 27 I showed you on the other one, right? So it's like $5 or $7 per square foot more, right? Okay, so how do we deal with that? Well, for one, we can go a lot faster. Like I said, we can go 8,500 square feet per week instead of 5,000. So that gain is to the owner and the general contractor's benefit, right? They can realize savings there. So I think that's where we got to get to be cheaper, right? We just got to go faster and get it on the market sooner, reduce the overhead costs, and there we go. So I think that's our solution, Jeff. I don't know if there's a better one, but that's our solution. As far as reducing the cost further, I think like we're just in its infancy now. Like I'm going to talk in general terms in terms of CLT, not just for light wood frame, but for any kind of CLT or mass timber structure. We got to get more standardization into the products. We've got to have like stop just doing like one-off designs, right? Like one job is like totally different than the next one. You got to get standardized methods and standardized connectors, off-the-shelf connectors. So you don't have to have them, uniquely fabricated for your job. In the bidding process, I know we're always competing against our supplier, and there should be a more streamlined sort of supply chain there. Procurement again, like right now every job is a custom job. And the install crew, highly specialized, not really. I think the problem with the install is most people don't have a familiarity with it yet. But as more people do these projects, that'll go away because it's really simple. I hate to tell you, but it's like dead simple. Anybody can do it. Yeah. And anyway, and then the end use to the owner. The owner's got to have a real good reason for going wood, and we have to make that case, whether it's cost, whether it's environmental, whether it's health benefits, whether it's low impact on your neighborhood. All those things have to be sold better than they are now. And then going to the future, I think we ought to improve our supply chain on the CLT. Of that $32 per square foot that we can do a CLT project like Virtuoso, most of that is the cost of the CLT, like $13 to $15 per square foot. So we can get that cost down by improving the way we mill the wood, by the time, improve the supply chain to get to the manufacturer. So it comes from the forest to the manufacturer to the fabricator to the installer in a more linear fashion than kind of like the way it's going now. Then if we get that cost down per square foot, that's like directly to the bottom line, right? If we reduce that cost from $15 per square foot to 12, then we're making some gains, right? And then to get more, like I say, more, proven designs that the architects and engineers can, draw on to produce the result that they need. And there's just one more thing. Can you go back to the Brock Commons slide? The Brock Commons? I just have to have something, one more. I just wanted to throw it. Yeah, see, this is the thing I wanted to bring about this. This is Brent's job, and he has a little slide here he's going to show you later about the cost of this structure and how this needs to be produced. You said 10. It has to be delivered about 10 to 15% faster to beat a concrete building on price, and I think that's doable with the right approach. We can certainly do that. So Brent's going to hang around after, and because I have a slide that he's better off to explain. If you want to come up after and ask questions, Brent will be here, and Nathan and I. And I think that's it, Jeff. So I don't know. We're not there yet, Jeff. I can't say we have an answer today, but I know we're going in the right direction. I feel it in my bones. Like I never thought, like 3 years ago, we'd ever see CLT going into wood frame, low-rise wood frame. I never thought, was that going to happen? I said, give up. It's not going to happen. But every week now we get more. Like it's happening, it's coming, because it's easier, it's better, it's cheaper, it's easier, better, faster, and it's becoming cheaper. Yay. Yay.